Hello everyone. I welcome you all in today's video topic, that is reliability versus availability. I, Professor Rahul Tute, Assistant Professor, Department of Computer Engineering, AISSMS IoT Institute. In reliability and the availability is basically related to the data management and the replicated data management. Where the data replication is an age-old techniques for tolerating faults and increasing data availability and reducing latency in data access. With the online activities taking over the lives, our critical data, both personal and the professional, are being increasingly stored in data centers somewhere in the globe. Such data are replicated across the multiple data centers either proactively or reactively. Even when some of the copies are lost due to the crash or become inaccessible due to a network partition, or our data still remain intact and accessible. Catch copies of downloaded data on our personal devices that enables us to use them even if the network connectivity is upset. And apart from the data backup, the replication is widely used in the implementation of distributed shared memory, distributed file system, and bulletin boards. Basically the reliability versus the availability. The first thing is that reliability is nothing but is anything broken, and the availability is the system still available to the user. While we are accessing the replicated data and we are managing that replicated data for its availability and for its data accessibility. What is reliability? Reliability, we can say that there are two primary motivations behind the data replication are the reliability and the availability. Data replicated in the cloud not only serve as a backup and a safeguard against the failure, but also facilitate anytime, anywhere availability through a simple browser. It can be defined as the probability that the system will produce correct outputs up to the some given time t, and reliability is enhanced by the feature that helps to avoid, detect, and repair the hardware fault. A reliable system does not silently continues and deliver the result that include uncorrected corrupted data. Instead, it detects and if possible correct the corruption. We take one example here. By retrieving any operation transaction or intermediate error, or else for uncorrectable errors, isolating the fault and reporting it to the higher level recovery mechanism. Which may the follower to redundant replication, replacement of data and redundant replacement of hardware, etc. Or else by halting the affected program or the entire system and reporting the corruption. In web, proxy servers that provide the service when the main server becomes overloaded. All this illustrate how replication can improve data and the service availability. There may be a case in which the service provided by the proxy server is not sufficient as the service provided by the main server, but certainly it is better than having a no service at all. In availability, it is means the probability that the system is operational at a given time. That is the amount of time a device is actually operating as a percentage of a total time, and it should be operating. Highly availability system may report availability in terms of minutes or hours or downtime per year. The availability features that allows the system to stay operational even when fault do occurs. A highly available system would disable this malfunctioning portion and continue operating at the reduced capacity. In contrast, a less capable system might crash and become totally non-operational. We took one example where you can see there are two diagrams A and B, and consider these two users, Alice and Bob. They are trying to updating a shared file. We called it as a app. and there may be a single copy of F, or Alice and Bob each may wants to maintain a private replica of F. So in this figure, you can see how that user's file are going to access. In Alice and Bob, they are sharing the file F. So in A, they are accessing the same file which is shared amongst them, and in B, you can see they are accessing the replica copy F dash and F double dash. So do they have true? They are checking the condition true. Then it will be read that file, then modify that file and write that file, and then end. So depending this, how that file is going to maintain, and the write operation in first we consider case, the one will update the central copy of F, and that is shared by both two. Okay, and or will update the local copies of F separately maintained by the Alice and Bob. In figure B, you can see. So in either case, ideally, we can say the Alice updates must reach Bob before he initiates the read operation, and the vice versa. So, however, with these separate local replicas, this may not be possible due to the channel latencies. So, Bob may either read the stale copy or postpone reading until the update arrives. So, what is an acceptable semantic of the sharing file F? So this will be depend on the data consistency model. So it means whenever the first file is get received its read operation or write operation, then later on the second users will start to editing it or start to modify it. So this is how your reliability and availability must be take place over the distributed system. So whenever you are trying to sharing any file, so how it will be going to execute if if one file is shared amongst the between all the users, and what happen if we are applying the operation on separate replicas of that system. So thank you for this. We will meet in next video.